Hello class, welcome back. We are now in section 2. This is page 374 in your books. We're in chapter 12, section 2. So what we want to do now is in section 1, we calculated what the future value of an ordinary annuity was. And ordinary annuities, remember, the payment is made at the end of the compounding period. So at the end of the compounding period, interest is calculated, payment made. All right. An annuity due, the payment is made at the beginning of the compounding period. So that payment resides, and then at the end, interest is calculated. All right. So that is a major difference. So let's look how that works. Now, just as we did in section 1, we're going to look at how to manually calculate it out. We're going to look at basically the same problem as we did in section 1 when we calculated it manually. $10,000 per year for 4 years at 6% compounded annually. So, and then let's figure it out for an annuity due. That means the payment is made at the beginning. So we use a simple interest formula. When we do that, the beginning of period 1, at the beginning of the period, we make a payment of $10,000. So the first payment is made. So we figure when we get to the end of the period, we calculate interest. There's $10,000 in there, so we need to calculate that interest. 6% compounded annually is a 6% per interest rate period. And then we're calculating it for 1 year. So as we calculate that, that's $10,000 plus $600. We should get $10,600 at the end of the period. So $600 interest plus $10,000. Now, let's get the beginning of period 2. We carry over from period 1, $10,600, and we made a new payment of $10,000. That's at the beginning of the period. All right, so now when we calculate interest at the end of the period, we have to add those together. We get $20,600 times the 6% interest times 1 should give us $1,236 for interest. So now we have $21,836.00. So at the end of the period, we pull that down to the beginning of period 3, $21,836, but we make another $10,000 payment, the third annuity payment. So now that is $31,836, all right, times the 6% times 1. So that interest is $1,910. And when we add that all up, we now have $33,746.16 at the end of period 3. So now at the beginning of period 4, we carry that down. We have another payment at the beginning of the period, so when we add those together to figure out our interest for this payment period at the end of the at the end of the compounding period, we now have $43,000 times 6% times 1. So that's $2,624.77, which, when we add that all together, is $46,370.93. So this is the annuity due. Now, what's the difference? When we calculated the ordinary annuity, all right, same terms, 6%. For 4 years, compounded annually, payment annually. All right? But the payment is made at the end of the period. So, for ordinary annuity due, for annuity due that we looked at just now, we paid at the beginning of the period. So we put $10,000 in right away. We don't do that here. So at the end, we pay our payment. But the interest has already been calculated on 0, so we just have $10,000. Now we roll that $10,000 down at the end of the period. We calculate our interest on that $10,000, which is $600. Then we make our payment. So now we have $20. So you see what happens here. So at the end we have $43,746. When we do the annuity due, all right, we actually have $46,000. All right, so just short of $3,000 extra. So what's the difference? Well, the difference is an extra interest payment. Because we're calculating interest on the first period and an annuity due, we get an extra interest payment, and interest gets shifted up 1 payment period. So we get an extra payment period of interest. So the difference, the main difference in an ordinary annuity and an annuity due is the number of payment periods. We get an extra interest period. All right. So when you are using the tables to calculate annuity due, all right, you calculate the number of periods of the annuity, years times the the compounding periods per the year, and then we add 1 because the annuity due we're calculating an extra term of interest. We calculate the interest rate per period. That's the same, nominal rate divided by periods per year, compounding periods per year. And then from table 1, again, we find our factor. So across the top is going to be the interest rate per period, and down the left-hand side is going to be the number of periods for the annuity, which we've added 1 to, right? Now, the major difference here. In the table itself, the table is set up as an ordinary annuity. So those factors are for ordinary annuities. All right? But for the annuity due, what we have to do is once we find our factor, we have to subtract 1. And once we subtract 1, we now have the annuity due factor. And once we have the annuity due factor, we calculate that by multiplying for the future value of an annuity due. We multiply the annuity due factor, and that's the ordinary annuity minus 1, times the annuity payment. All right? So, as practice. All right? Example 2. Chris deposits $60 at the beginning of each month. That sounds very doable to me. For 2 years at his credit union. If the interest rate was 12% compounded monthly, who can say no to 12%? We're going to use the table to calculate the future value of Chris's account. But notice it's at the beginning, so it's annuity due. So the tables are for ordinary. Remember, the steps are find the compounding periods. So in this case, it's for 2 years, and it's monthly, so that's 24, and then we add 1. So we're going to use 25 as the number of periods. The interest rate per period is 12% divided by 12, and that's 1%. All right, that's 1% per month. The ordinary annuity table factor at the intersection of 25 and 1% is 28.24320. I'm not going to flip over there, but that's what it is. Then we know, because that is the ordinary annuity table factor, we have to subtract 1, and so the ordinary due table factor is 27.24320, which the future value equals the annuity due factor times the annuity payment. So the future value is 27, the annuity factor, times 60, which is $1,634.59. And if we figure out quickly what he paid out of pocket, $60 a month, so 60 times 12 is $720 for 2 years is $1,440. So just short of $200. So he made just short of $200. All right? Which is pretty good. That's free money. Remember that. Savings is free money. And the interest earned on savings. So, try an exercise. The Vista Savings and Loan pays 6% compounded quarterly. All right, calculate the future value of $1,000 deposited at the beginning of every 3 months. So the interest rate is compounded quarterly and the payment is quarterly every 3 months. Figure that out for 5 years. All right, so go ahead and figure that out. Remember what the difference is for annuity due versus ordinary annuity, and calculate that out. All right, when we come back, I'll show you the answer.